Hello everyone, I'm Xiang from the University of China's Academy of Sciences. Today, I'm honored to bring our paper, a subject-aware attention hierarchical tiger for joint entity and relation extraction. Entity and relation extraction task aims to extract triples containing entity pairs and their semantic relations, represented as subject, relation, object. It's a key technology for knowledge graph construction, which has received increasing attention in recent years. Now, this extraction task is divided into two main methods. With the development of neural networks, the joint method has been widely studied. It detects entities and relations from unstructured text by a single model. But this task becomes challenging due to the problem of overlapping relational triples and the lack of internal interaction of triples. Overlapping relational triples contain three cases: normal single entity overlap and entity pair overlap. A sentence belongs to the normal class when all of its triples have no overlapping entities. A sentence belongs to the SEO class when some of its triples share a single entity, such as Steve Jobs. A sentence belongs to the EPO class when some of its triples have overlapping entity pair, such as China and Beijing. However, existing models based on joint method either don't fully address all cases of overlapping relational triples, or they just apply the results of the previous part to the subsequent extraction work, ignoring internal interaction of triples. So we propose a subject-aware attention hierarchical tiger named CAiSE22 for joint entity and relation extraction. We first introduce our tagging scheme. We use subject tiger and object mounted relation tiger to perform sequence labeling tasks. An entity may include multiple tokens, so we predict entity positions, including the start and the end. Subject tiger labels its type at positions of each subject. Object mounted relation tiger labels the semantic relations at positions of each object. This is our model. First, we encode the input text by a shared bi-LSTM encoder. Each token in a sentence contains three parts: the pre-trained word embeddings, the part-of-speech embeddings, the character-based word features. Second, the subject tiger can identify all the subjects in the input sentence. As discussed in the tagging scheme, the positions of entities are divided into start and end, so it adopts two linear layers to predict their type at positions of subjects. We optimize the loss function for the subject tiger. In a triple, the extraction of object and relation is based on the subject and context information. According to a shared encoder and subject tiger, we can get subject features, including its semantics and type. So we use a convolution layer to extract the subject features. The words in the sentence play different roles under the different subjects, resulting in different context information. So we propose a subject-aware attention mechanism. This mechanism calculates the relevant weight for each word in sentence by the subject features. Finally, we get the sentence representation and the subject features. Similar to the subject tiger, the object mounted relation tiger also uses two linear layers to predict the relation type at the start and end positions of objects. The difference is its input fully incorporates the subject information. We not only add the sentence representation, but also add the distance representation between each token and subject. The other difference is that the object multi-relation tiger needs to implement a multi-label strategy at the positions of the object, because there are multiple relations between entity pair. Therefore, here two binary classifiers are adopted to determine whether the current token is the start and end positions of the object for each relation type. Finally, we get two losses. We add them together as the final loss to achieve joint training. In the experiment, we use two public datasets, NYT and WebNRG. To compare with previous models, we split datasets according to the data pre-processing method provided by this paper. This table shows the number of sentences for normal, SEO, and EPO classes. We use precision recall and FE score as evaluation metrics. This table shows the main results. Such performance gains are attributed to the following reasons. Number one, subject-aware attention mechanism provides a selection process for the object and relation extraction, aiming to select context related to the subject. Number two, object multi-relation tiger introduces a multi-label strategy, making it possible to extract more relation types. Besides, we conduct ablation experiments on NYT dataset to verify the effectiveness of subject type, CNN for subject features, and subject-aware attention. We delete one component at a time to observe the changes in experiment results, which are summarized in table. To illustrate the extraction ability of our model, we conduct further experiments on the NYT dataset. Number one, different cases of overlapping relational triples. Number two, different numbers of triples. As shown in figure, our model outperforms all other models. We select two tests from the NYT test set for case study. As shown in table, in the first case, the predicted results of our model are still the same as the ground truth for such complex sentence. This case further illustrates the strong extraction performance of our model for complex tests. In the second case, we find that this model can be used as a triple tagging tool in incompletely labeled datasets. This is a significant advantage of our model in that it is able to extract more possible triples in tests. In summary, we propose a joint entity and relation extraction model named CAiSE22. Due to its hierarchical extraction strategy and the multi-label strategy, our model is more suitable for the extraction of overlapping relational triples. And we apply the subject-aware attention mechanism to construct different sentence representations under different subject features. It realizes the internal interaction of triples. And experiment results on NYT and WebNRG datasets show that our model gains great improvement. And our model can be used as a triple tagging tool to extract more possible triples in tests. These are references. Thanks for listening. Thank you.